Hello, this particular podcast is designed to help you understand empirical formulas a little bit more. And what you want to do is get out your worksheet that goes along with empirical formulas, because in order to help you, I'm just going to use problems right off of that worksheet as an example, or as examples. So you want to take out that worksheet, and the problems I'm going to work for you are going to be problems 1, 7, 9, and then I'm going to go back and do number 4. Okay, so have those handy and we'll work through them. You'll, number 1, get part of the worksheet completed, and number 2, hopefully learn how to do these problems better as we go. So here's problem number 1. Okay, and remember, with empirical formulas, there were 4 steps. Okay, and the first step was to change percents to grams. And the reason why we're doing this is we're saying, well, if I have 100% of something, I'm going to pretend I have 100 grams of whatever that compound is. That way, if 63.5% of this 100, okay, is silver, then 63 grams of it would be silver. Okay, so that's why we can make this change. So first thing we're going to do is take the percents and we're going to change them to grams. So I have 63.5 grams of silver. And the way I like to do this is line them up right along the page, okay, because we can do everything for these problems right in a straight line. So then I'm going to change the 8.2% of nitrogen to grams. And the last thing I'm going to do is change the 28.2 grams of oxygen, or percent of oxygen, to grams. So that was step 1. Step 2 then, if you remember what a formula is really a mole ratio. So in step 2, what we're going to do is we're going to change all of these to moles by looking up the molar masses of these elements on the periodic table. So the molar mass of silver is 107.8 grams, and we get that right off the periodic table. The molar mass of nitrogen is 14 grams. And the molar mass of oxygen is 16 grams. And we're putting 1 mole on top over the actual mass. Okay? And what that does for us is it cancels all of our grams. So now we do this second step and we actually do the calculation. Okay, so we get that many moles of silver. And remember, I said in the first VodCast, you want to keep at least 3 decimal places on most of these. Okay, and you don't really want to round too much on this particular step. Okay, so that's how many moles of nitrogen you have. And then the last one, that's how many moles of oxygen. Okay, so that was step 2, change your grams to moles. Step 3, find which of these is the smallest and divide all of them by that smallest number. And the smallest number here happens to be this one, 0.587. So that's going to give me 1 mole of nitrogen. And if I divide this by 0.587, that's essentially 1 mole of silver. And if I divide this bottom one by 0.587, that turns out to be 3 moles of oxygen. Okay? So that was step 3. And these numbers here might not come out to be exactly 1 mole, but at this point, you round to the nearest whole number. Okay? So you round to the nearest whole number. Now, okay, I wouldn't expect you to do this next part, okay, but what we have right now is 1 mole of Ag to 1 mole of nitrogen to 3 moles of oxygen. That's my mole ratios that I currently have, which you can see those right here. Okay, so you probably don't really need to write this statement out. But our last step then is to write the formula And the chemical formula of this would be AgNO3. So that would be my final, simplest formula. Okay? So those are the steps. Okay? We're going to do number 7 because number 7, as an example, gives you a little bit of a twist. Okay? So again, step 1, change the percents to grams. So I'm going to have 70 grams of Fe, and I'm going to have 30 grams of oxygen. That's step 1. Step 2, change the grams to moles. Okay, so I look on the molar or the periodic table and find the molar mass of iron, and that's 55.8 grams. And I find the molar mass of oxygen, and that's 16 grams. And I do the calculations, so this comes out to 1.25 moles of Fe, and this comes out to be 1.875 moles of oxygen. So that was step 2. Step 3, divide each one by the smallest number, which in this case is 1.25. Okay, so this comes out to be 1 mole of Fe, and this comes out to be 1.5 moles of oxygen. Okay. Now, you have a problem. This 1.5 moles is really not close enough to 1 to round down. Okay? So you can't round this down and you can't round it up. Neither one would actually work. So what happens whenever you get a 0.5 of something, with that 0.5 of whatever it is, you're actually going to have to multiply everything by 2. Okay? So I'm just going to rewrite what I have right now. Okay, you don't need to rewrite this, you have it. You should be able to fit what I want to do on the rest of your page. But you have 1 mole of Fe right now, and you have 1.5 moles of oxygen. Okay? So what I need to do right now is I need to take both of these and multiply them by 2. Okay, when I do that, I'm going to end up with 2 moles of Fe, and now I have a whole number of oxygens. Okay, so whenever this number, or one of these numbers in step 3, comes out to be 1.5, okay, you're going to need to multiply by 2. Now I can write my formula, Fe2O3. And that would be my final, simplest formula. And hopefully you would understand and realize that Fe2O3 is a good formula. But if you just wrote FeO2, okay, hopefully you've done enough formulas where you realize that, well, that just doesn't even make sense. Because when you get done with these simplest formulas, for the most part, they should be recognizable. Okay, let's look at this one. Now, this is number 9 on your sheet, and I chose this one as an example for the main reason that you're already given grams. So the first step, which is change percents to grams, you do not need to do. I already have grams, so I can go ahead and just start with 4.78 grams of potassium, and I can have 6.37 grams of chromium and 6.82 grams of oxygen. Okay, and then we can just go right into the second step, which is to change grams to moles. So from that point, okay, these problems don't change. Okay, so I'm going to look up the molar masses of all of these. Okay, so there's all my molar masses, and I'm just going to do the math here. So this first one comes out to be this many moles of potassium. This one happens to be the same number of moles of chromium, and we're just doing the math right now. Okay? So what's step 3? Divide all of these by the smallest number. Okay, so 0.122 is the smallest number. So this comes out to be 1 mole of potassium, 1 mole of chromium, and 3.5 moles of oxygen. Okay, so there's your issue again. Okay, I have a 3.5 in here. This 3.5 right here is not close enough to round up or down. I do not want to round that to a 4. So what I have to do is take all of these and multiply them by 2. And unfortunately I ran out of space here. But when I do that, then what I get is 2 moles of potassium, 2 moles of chromium, and 7 moles of oxygen. And so now from there I can write my formula, K2Cr2O7. And that is my correct formula. And hopefully you realize that Cr2O7 is the polyatomic ion dichromate. Okay, so there's a couple things in this particular problem. Number 1 in this particular problem, we started with grams, so I could just put the grams as my starting numbers. And then we got that 3.5 issue again, where when we get 3.5, we want to multiply everything by 2. The last problem I want to go through is, I'm just going to go back, and I just chose a problem here. We'll just work through number 4. And there are no major issues in number 4. But I thought I'd just work through one more just in case you didn't really catch on yet. So the first thing we're going to do is change percents to grams. Okay. Next thing we're going to do, molar masses. Okay, do the math. Okay, so there's my math. Divide all of them by the smallest number of moles, which is the 0.72 in this case. So this math is going to come out to be 1 mole of carbon. This one comes out to be 2 moles of potassium. And the bottom one comes out to be 3 moles of oxygen. So there's nothing really special here. There's no odd numbers or anything like that. So we should just be able to go ahead and write the formula for this, which would be K2CO3. And that would be our final formula. So hopefully this helps with some more examples of writing empirical formulas.